This video is about activation energy. So the key in the question is, how does increasing temperature affect rate constant K and activation energy EA? And the concept of this question is understanding the relationship between terms of the Arrhenius equation. So this is the Arrhenius equation, and we're going to plot this on a linear graph. So on the x-axis we have 1 over t, on our y-axis we have ln k. The graph would look something like this because the slope is negative EA over R and our y-intercept is ln A. So we can see the term R is not a variable because it's a pre-existing value. And our term A and EA, which is our frequency factor and our activation energy, is not affected by our temperature or our rate constant, because A, which is the frequency factor, determines the probability of the molecules colliding at the correct orientation for a chemical reaction to occur. So we can sort of understand it like the starting point of our graph, and our slope, which is determined by our activation energy, which is determined how much initial energy you need to overcome that threshold for a chemical reaction to occur. And the only two variables that is changing, which is temperature, our x variable. So as temperature increase, it would affect rate constant, which is our y variable. And we know that from this graph, we can see if we increase temperature, the value ln k decreases, but the value k increases because we're increasing temperature, meaning we're adding more heat and energy, and so our chemical reaction will occur at a faster rate. So the rate constant will actually increase. So if we were to go back to our question, they asked, how does temperature affect rate constant and activation energy? So we know increasing temperature increases rate constant but doesn't affect activation energy. So our final answer is C.